So we're looking today at shells and orbitals. So what I'd like to do is go back to that model of an atom that we had at GCSE. And if you remember, we have a nucleus in the middle. And we've been saying that it's a positively charged nucleus which is holding these negatively charged electrons around the outside of it. Now we've also got electrons held within shells. That's what we've been talking about up until now. 2 in the first shell, 8 in the next one, and in the case of sodium there's 1 in the outer shell there, 1 electron in the outer shell. This shell here, the inner shell of electrons, is the lowest energy level, so it's the first energy level. And then if we go to this next shell of electrons here, that's the second energy level, and the outer shell of electrons here, we've got another higher energy level there. So each shell is basically the equivalent to an energy level. It has a principal quantum number n. Each of these shells can hold 2 n squared electrons. So if we are in the first shell, how many electrons will there be inside? How many in the second shell, third shell, and so on? Just pause now and have a go at that. So we've said that we've got the first shell here, and this is equivalent to a first energy level. Now in this first shell, the n is 1, it's the first shell. So if we're saying there are 2n squared electrons in this shell, then 2 times 1 squared is 2. There are 2 electrons in the first shell. We go to the second shell, then n is 2. The principal quantum number is 2 because it's the second shell. That means there are 8 electrons because 2 squared is 4. and 2 times 4 is 8. So we can start with a few definitions here. So an orbital, and we'll talk about what we mean by an orbital in a minute and the shape, but an orbital is a region within an atom that can hold up to 2 electrons with opposite spins. And again, don't worry about this word spins at the moment, but the point is that it holds 2 electrons. Each orbital holds 2 electrons. A shell is a group of atomic orbitals with the same principal quantum number, so this is this n that we've just been talking about, or an energy level. So it's a group of atomic orbitals with the same principal quantum number. In other words, it's in the same energy level. And then within that we've got something called a subshell. At GCSE we've been looking at this kind of structure of an atom, and so we'd be talking about a shell here. This is our first shell, but this orbital, that's a bit more difficult to kind of fit into this structure, and we have to move on to this kind of diagram here where we've got shells and orbitals and basically boxes to represent what is going on. What we do from this stage onwards, when we're talking about electron configurations, is we represent each orbital with a box. So here is an s orbital, and this orbital, this s orbital, can hold up to 2 electrons, and I'm going to draw them like that for now. I'll come back to why that is later. Here is my p subshell. Now my p subshell contains 3 p orbitals. Here's 1 p orbital, so each box is an orbital. Now you have to get this language right, it's very easy to get confused. Each p subshell can contain up to 6 electrons. Now I'm filling it like this, and I'm drawing the electrons like this. D subshell can contain up to 10 electrons, and the F subshell here can contain up to 14 electrons. There are 7 F orbitals within that subshell too. And what I asked everyone to do when I taught this last time was to just take a bit of a break here and walk around and then come back and look at these. And if we scroll down, you can see here a gymnast, and what they've done is they've done multiple exposure shots of a gymnast, and so you can see her all over the place because actually what she's doing is swinging on a bar. So here we go with a weightlifter. And we're going to use this next time when we talk about electron orbitals and the shape of orbitals, and then move on to talk about electron configurations.